Okay, we're going to evaluate the antiderivative of this function using integration by parts. That's the same. We can pull the 3 out front, and we're going to evaluate this integral, which requires integration by parts. So here's part A. What's the antiderivative of x squared cosine of mx? Where, of course, m is a constant. Let's let u equal x squared, and then d equals everything else. So du is 2x dx. And v, the antiderivative of cosine mx, is 1 over m times the sine of mx. And you can mentally take the derivative of this to make sure you end up back here. Okay, and then using the formula for integration by parts, u times v, which would be x squared over m sine of mx, minus v du. Well, v has a 1 over m constant, and du has a 2 constant. So 2 times 1 over m. Move that out front. Antiderivative of x sine of mx dx. And this too requires integration by parts. So I go over to part B. Same deal. U equals x, dv equals antiderivative of sine of mx. Here's what we get. And we still have to evaluate this portion. So this b that I'm going to return over here is minus x over m cosine of mx. This is plus 1 over m times the antiderivative of cosine of mx is 1 over m sine of mx. So that's b. So now when I get back to the original, I'm just going to start writing down 3 bracket a. What is a? A is this. So I'll start writing this down. X squared over m sine of mx minus 2 over m times b. Here's what b is. Minus x over m cosine of mx. It's kind of hard to read there. Plus 1 over m squared sine of mx. And then I can remove this bracket by distributing the minus 2 over m. You get 2x over m squared cosine of mx plus, or no, actually minus 2 over m cubed sine of mx. And here's where I finally add the constant of integration. Then you could distribute the 3, although that doesn't accomplish a lot. And if I go to board 2, here's kind of a way to prove this on Desmos. Here's the antiderivative. You could put a plus c out here if you wanted to. And if I take the derivative of that, I should get what we started with. So there's the derivative. If you actually go to Desmos and look at these two graphs, they overlap each other. And this was the the function you get when you take the derivative of big F little f. And this table seems to confirm that this is the correct answer. Okay, there you go. Hope that helped. If you have any questions, post a comment.